Hey everyone, welcome to AI Agents Unlocked. This is our podcast, and today's topic is scaling the future and building high volume agents for high volume environments. So, our guest today is Nithin Mohan. He's an AI supercomputing leader at Hewlett Packard Enterprises, HPE, and where he has led AI ML platforms used by top supercomputing customers, and will unpack real architectures, reliability, and cost wins. And also, Nithin here is one of the very few engineers I know who has scaled a startup from 0 to 1 and has seen it through the acquisition. So we'll be talking about that as well. So let's jump right in. And Nithin, welcome to our podcast, and hello to you. So, in one line, what does high volume AI agents mean in an HPC context, right? And what is sort of the SLO do you guard first? Like, is it the P95 or is it P99 latency? And what is the success rate and like sort of you know cost per task?
Absolutely. First of all, thanks for having me, Keshavan. I've been following the podcast, so it feels great to actually be a guest on the podcast and contribute. So, jumping on to the question, so in HPC, high volume agents means agent workflows that must sustain thousands to tens of thousands of concurrent tasks with strict SLOs while riding bursty batch schedulers. So the
Mhm.
first SLO we try to guard usually is success rate, then P99 latency, and then cost per task. Because as you can imagine, a fast or cheap wrong answer is still a failure at that scale. So
Mhm.
the SLO that we always start with is success rate.
Right. Thanks for the quick introduction. And let me dive a little bit more deep into your background, right? I know you built Solid Fire, which is like a flash storage system,
Mhm.
right? Uh, and then it was acquired by NetApp. And so, what is sort of this startup journey that you had to go through, and like what lessons did you learn, and like if you could share that with us, that would be really awesome.
Yep. So, I was fortunate to start for a startup that was, deep doing distributed systems for scale out flash storage. And one lesson I have carried forward into my current job and intermediate jobs, I would say, is, uh, you know, first was scale out systems taught me to design for tail latency, right, and to treat every failure as the default, right, and building AI ops and observability platforms, even during my NetApp and Solidify days, taught me to instrument everything and close the loop from signal to mitigation. So that combo of distributed systems plus ML in production, our lessons have carried over at HPE to make AI agents reliable at high performance computing scale.
Obviously, right? Like when you talk about AI agents, you want to be able to build it at high volume, right? And your background is very relevant in that sense, right? So, what is sort of the um design that you follow in terms of building these AI agents?
Sure. So usually, the premise is always to keep things simple, right? And if you talk about AI agent patterns, uh, there are obviously many, but a tool-centric single agent pattern with clear orchestration usually wins in terms of throughput and simplicity, right? And there are other patterns like hierarchical and planner executor, but you know keeping it simple, even at high performance computing scale, even at exascale, uh, is usually the trick, right? There are obviously cases where you need the other patterns, but if you ask me what holds up at scale and keep things less chaotic, it's, I would say, starting with simpler things like tool centric single agent pattern, but with clear orchestration. Coming on to the other patterns,
Mhm.
even though they are used on a case by case basis, I would like to highlight, right, hierarchical pattern helps for complex plans,
Okay.
but the limit is it usually cracks under cross team or cross tool latency variance and state sharing. And planner executor works, but you have to really orchestrate it and put in cap planning steps, caching plans, and force tool budgets to control tail latency. So there are cases for those patterns, but what I've observed is
Mhm.
simple pattern like tool centric single agent wins the day usually.
Right. I mean, I want to dive a bit more deep into this thought, right? Like about building tools centric AI agent, right? Like, so when you build tool centric AI agents, what if the AI agent has to make multiple tool calls, and you know, and then what happens to, say, sort of like the number of tool calls being made, or like how do you design for burstiness, right? What do
Yep.
you put in place?
Yep. So the heuristic is always to plan for floods and not rain, right? So using priority queues effectively, for example, interactive or batch, using token bucket rate limits, uh, using the right back pressure from workers to ingress, right? And idempotent retries with jitter, right? Watching for queue depth, in flight per worker, retry percentage by cause, and generally P99 tail latency end to end, right, are some of the design considerations uh, for AI agents at scale, right? So those are some of the immediate things that stick out from my experience, is what I would say.
Right. Obviously, that's very technical. And for our non-technical audience that's listening to this podcast,
Yeah.
what would you, you know, how could you simplify and like make sort of everyone understand?
Sure. So to make it slightly middle of the ground in terms of technicality, I would say treat every tool in your ecosystem, every tool call in your ecosystem like an RPC call in a very chaotic network, right? So you're trying to isolate and trying to have observability around every hop, is how I would put it. To and that's a design and also hedging that usually saves the day many times when you're trying to debug and figure out what's going on.
Right. And when you think about these AI agents, right, like they perform multiple tool calls, right?
Mm,
Maybe calls to the database, maybe they search the web, or
mm,
make some API calls, right?
yeah.
So when you design an AI agent, there's like multiple components associated with it, right? Like all these tool calls, and they call certain APIs. And
Mm,
then you also have like LLM calls, right?
mm, mm,
LLM calls have their own sort of latency, and depending on the model, it could be 10 seconds, or it could be 5 seconds, or it could be 30 seconds, right? Like, so how do you sort of think about latency when it comes to designing these AI agents?
sure. So interestingly, tool latency often beats model latency, right? Model or LLM latency is usually never the culprit, right?
Hmm.
So that's why, going back to my previous comment about, and I'll expand on that, treating every tool call or database call or search or API call like an RPC call in a very chaotic network uh, helps in production and when it comes to debugging an outage or an issue quite significantly, right? And what I
Mm-hmm.
mean by that is, in terms of tool calls, uh, you know, using a series of chain of steps to your benefit,
Right.
timeouts, budgets per step, timeouts per tool call,
Right.
budgets per step, right? Concurrent hedge request for endpoints are flaky, early partials, right?
Mm-hmm.
And semantic caching of expensive lookups, right? These will help tame latency,
Mm-hmm.
right? And always it's good to attribute latency per span of your search, so that LLM doesn't take the blame, right? Because, like I said, LLM is usually never or the model is usually never the culprit.
Right.
Yeah.
In terms of designing these AI agents, right? Like one of the things that is important is like the memory, right? And it's sort of important. The way I see it is like, you want to maintain a long context workflow. Maybe, the AI agent calls another AI agent, or it calls a bunch of tools, and there are sort of things happening, right? So in terms of memory, what is persisted and maybe in for long duration of time versus what is in the context for what sort of context is persisted for short period of time, and what's persisted versus what is ephemeral. Yeah.
Yep. So a good heuristic that does the trick is persisting facts and durable state. By that I mean, IDs, decisions, ACL relevant context, and keeping ephemeral scratch, right? So think intermediate tool IO, keeping that out of hot context and instead summarizing it is a good pattern. And using key value caches and structured memory stores so that the prompts reference IDs instead of blobs, right? That's usually cheaper and very audit friendlier as well. So when it comes to memory, I think these are usually the right series of uh,
Mhm.
design patterns to go for.
Right. Um, let's also think about the sort of the user perspective, right? So when the user, works with an AI agent, right? Like, what is sort of the, what is something that they see, right? Do they see all of this? Like, I mean, of course, they experience latency or experience, that the AI agent is doing some sort of tool calls or thinking or doing some of that. But then, in order to actually show it to the user, right? What is something that has worked for you in your experience? Uh, like, what do you show to the user, right?
Sure. So in terms of the user, right, they are sitting there waiting for a response, right?
Yeah.
And while your system is orchestrating and handling a prompt, uh, from a user perspective, having guardrails without killing throughput is usually a good, I would say hack, right? So running cheap inline detectors, right? Lightweight classifiers before even the model runs, and running then deeper checks asynchronously where possible, right? For instance, keeping a single compiled policy so that decisions are always linear time, right? And caching policy outcome so that the user gets a quick response at least, while having a pattern such that you are telling the user this is something quick, uh, and a deeper response is being searched for, right? So those are uh, some UX friendly hacks to put in place so that the user experience stays, when you're sitting and waiting for something, if you get
Mhm.
something early, that's still helpful, right?
Yeah.
while knowing, okay, you're gonna get something more deeper in a while, right? So
Right.
great question, right? Usually uh, these tend to be overlooked, right? But there's so many things you can do to make the user experience more friendly.
Right. When it comes to, I mean, I think of like ChatGPT, right?
Yes,
Like,
yes,
what it does is it just says, the
thinking.
agent or the ChatGPT is thinking, right? Sort of thing is what is displayed to the user. But
Yeah.
then, like, going forward, right? Like, what is sort of the changes you see in the dashboard you might expect to see in the dashboard? Is it like, this particular tool call is made, or and it takes this much time, and then also give the user some sort of like estimated time of arrival or ETA for the
Mhm.
uh, answer,
Yeah.
depending on the question, of course. Like if it's cached, it comes more instantaneously, right?
Yeah, yeah. So in terms of, there's always dashboard metrics are not relate to the user, right? So
Hmm.
very helpful metric to relate to the user is just expected, response time
Yeah.
is something that's always helpful. What else? Yep. Very clear signals like thinking, right? Thinking for a deeper answer, so it may take longer, right? Something like that is always helpful. So early signaling, even if in plain simple words, uh, is always helpful from a user pattern. But when it comes to dashboards, on the engineering side,
Hmm.
one should try to keep a view of, especially when it comes to live dashboards, it's traffic versus saturation, right? Such as what is the concurrency and queue depth, and latency breakdown. So models versus tools versus queuing, having a clear latency breakdown helps you debug better and optimize better. And also having a dashboard view of top failure modes, whether you're being rate limited, whether your tools somewhere in the chain are timing out more
Hmm.
than the other calls, and how effectively is your caching working, cache effectiveness, right? What's your
Yeah.
hit rate versus tailness? Your hit rate ideally should be very high, right, for optimal performance. So yeah.
Yeah, I mean, this all ties back to regular software engineering concepts,
Exactly.
more than like something that is AI agent, or right. So
Mhm.
I think regular software engineering design principles and those system architecture still holds true, even
Yep.
if you're about to build a
Exactly.
new
Yep.
AI agent, right?
Yep. Yep.
Um, and in terms of like auditing, right? So like what are the things that you would want to log, right? Like auditing and logging perspective, right? Do you log every single tool call? Do you log every LLM or LLM call that is being made? What do you do in that case?
Yep. So usually, these are the important things for audit logs, right? So structured logs with IDs, timestamps, and the span links, right? Through not just the model, right? The
Hmm.
entire span of the call, and then storing prompt variables, but redacting sensitive values. That's very
Hmm.
important for compliance. And data residency tags, which are attached to artifacts, right?
Hmm.
And usually, not usually, right? It's always a good practice to log a trace replay path for
Hmm.
debugging without raw. Uh, uh,
Yeah.
yeah, yeah. So
I mean, looks like we need to log every part of the system, right?
yeah.
Um so W- have you ever implemented caching for AI agents? And like when you do so, did you do it at the tool call level, or did you do it for the entire system, like AI agent plus tool combined? Like maybe the user asks the same question twice and they get the same answer, right? Or
Mm.
was it more so for the tool level, right?
Yeah, so it's usually a combination. It Because model calls are more expensive, it behooves anyone designing AI agents at scale to uh, pay more close attention to caching, more close to the model, right? Tool
Mhm.
calls, right? You can do it through a combination of regex and lightweight classifiers, right? So uh, you have a hierarchical, step up approach where the more expensive the operation, the more beneficial the caching, right?
Mhm.
The more expensive, the more, and also the more latent the operation, more latency heavy the
Mhm.
operation, the more beneficial the caching. So definitely starting with heavy emphasis of caching at the model link layer, and then uh, for example, right, at the you can regex something, but does it help to cache something at that
Mhm.
layer? I would say not, right? So but lightweight classifiers, again, they usually run very fast, so there's not much cost or latency concerns. So you don't need heavy caching there, but if if you know there's going to be a hot spot of any specific data calls, then it makes sense to have some caching, right? Not to go overboard with caching, but some caching. So I would say that that's your heuristic, right? More
Yeah.
expensive, right? And
The ones that are more expensive, you
yeah,
just start
yeah,
caching them, right?
yes, yes.
That makes a lot of sense, right? Like now, I mean, I want you to sort of compare
Mm,
the different cost wins that one could obtain, right? Like
mm,
one of the methods is again caching and reusing the same response for either for the tool or for the agent itself, right? And then another method I could think of is like compressing the prompt, right?
mm,
Maybe like you make an LLM call, but then like if your prompt itself is huge, then the the cost is also bigger. And then there is also like small model routing, which is like dynamically based on sort of the user's question. I either route it to a larger LLM or to a smaller LLM, right?
mm,
And then another method I could think of is like if you're sort of using your own models, and you or like you're using more so of a distilled model, which is like you have a larger model in place, but then maybe you went with a distilled model,
mm,
and that sort of gave you a better cost win, right? Maybe
mm.
instead of say something like llama 70 billion, you went with like llama 3 billion or free, just so for an example, right? So what is sort of the different um, cost wins you've observed, and or have you sort of implemented all of this?
Yeah, yeah, definitely right. Because without implementing for cost efficiency, your budget is gonna just blow up of all the resources you would need to put in place to make this effective.
Yeah.
So the biggest cost wins, I would say, reusing responses, right? So response reuse and
Hmm.
semantic caching are uh, have been the top ROI, right?
Hmm.
Return on investment. And you made a point about prompt compression, and that also comes in, right? So adding prompt compression, right, such as structured templates plus references, uh, that's uh, uh, that's also has also proven to be very cost effective and a big cost win.
Hmm.
And in terms of modeling, right? So small model routing to smaller models for classifying and extracting transforms, and tool first always to avoid querying the LLM at all. So if you can avoid querying the LLM at all,
Yeah.
that's the biggest cost win, right?
Yeah.
And yeah, that's yeah, great question, but it's amazing how just simplicity can save the day in engineering complexity a
Yeah.
lot. Yeah.
And in terms of say API calls, right? You make all these external API
Hmm.
calls, and then vendors or the external APIs, the vendors that manage these APIs, they have sort of their own rate limits, right? So, is that something you would take into consideration while building your system?
Um, Absolutely right. Interestingly, in our case, we don't have external, or at least in the ecosystem I've worked in, we don't have external vendor calls or
Mhm.
calls to external third-party
Right.
APIs. But it's a very common problem, right? Or common use case. So just thinking it through, designing a capabilities router such that you define tasks in terms of required traits, right? Whether it's
Mhm.
JSON strict or long context or low latency, and supporting on-prem calls for data gravity cases, right? So keeping an API first abstraction with per vendor rate limiters and budgets,
Mhm.
and rotating vendors without changing business logic,
Right.
right? That's an effective hedging strategy to keep your core business use case less volatile.
Right.
Yeah.
To simplify to our listeners, what Nithin is saying is he would use DuckDuckGo or another search engine or Bing or some other search engine if Google doesn't let him make the search API call. Right.
Yeah, that's
Um,
what Keshavan.
yeah. I want to hear more about an example where you did like an end-to-end deployment, and like what is sort of the architecture and the bottleneck you had, and like how did you sort of um, how did you sort of enable your system to handle larger um, throughput or stability, like better stability in that case.
Yeah, yeah. So for version one of any deployment, it's good to start, like I said in the design patterns question, single agent plus tools, right?
Mhm.
Is always a good first step to start, and it's usually always the most of the times the final step as well. You don't need to go beyond that, and then using FIFO queues, unbounded retries,
Mhm.
uh, you know, hedging for larger prompts, and for bottleneck, having tool timeouts, plus retries piled up during scheduler bursts, right? And making sure P99 is never greater than 2 seconds, right?
Mhm.
And for uh, effective unlocks, having priority lanes, admission control, right? Bounded retries with jitter, which is a point I made earlier. And these factors are always critical to an effective architecture at scale.
Mhm.
And so the result of all these things that I mentioned, right,
Yeah.
is the initial SLOs for a V1 is always how can you have the P95 less than, let's say, 700 millisecond, have greater than 99.5% success rate, right?
Mhm.
Right. So if you design with these factors in mind, the result you're shooting for is, in our case, right, taking a leaf from my own lived experience, having we ended up with a P95 of 450 millisecond retries 60%, about 60% of the time, stability, right, up to uh, stability in the context of success rates greater than 99.5%. So in our case 99.7% was the stability, is has been the stability.
Mhm.
So yeah, bottlenecks, right, and first architecture is always interesting, and you learn a lot. So iterating is a important
Yeah.
uh, yeah it hack always, or important default always, I would say.
Yeah.
Yeah.
So, did it take like quite some time to build it, or was there sort of a first version? And like, what was your priority in implementing all of this?
Yep. So the starting with the SLO, right? So starting with a high SLO always in mind, because and then optimizing for cost and system efficiency.
Mm-hmm. Mm-hmm.
does the trick. Building in an SLO, especially a critical SLO, after the fact is very tricky. So
Mm-hmm.
starting in with that and then optimizing for the other metrics has been an approach that has worked well, Keshavan.
Yeah, and to summarize, right? Like, what are the top three things that any non-technical or even technical person should keep in mind while building an AI agent system that scales, right? Yeah.
Yeah. So, interestingly, always starting with the business objective, business case, right? You don't need a sword to cut an apple, is the saying, right? So, using across your span of user flow, all right,
Mm-hmm.
only having the agent be prompted when it's absolutely necessary, right, is fundamental, right?
Mm-hmm.
Because it's an anti-pattern is you hit the agent for everything, right,
Yeah.
without proper caching, without proper hedging in place for other latency or cost concerns. Ad ad does not, that can work for a toy problem, right, for something that's not production, any
Mm-hmm.
even non HPC production, right? We're not even talking about high performance or at scale, exascale environments. It won't work for any production period, right? Or it's not a pattern that will scale for any production, any enterprise production. So that's I've layered in many things, right? But
Yeah.
hopefully that
Yeah.
gives the point.
Yeah, I think there were definitely 3 points within that, and this was fantastic, Nathan. Thank you so much for joining us. And like one of the more important questions is, where can our listeners to our podcast follow your work?
Oh, absolutely. So I am quite active on LinkedIn. So LinkedIn is a good way to follow. My work. I post a lot, or I've started posting a lot about my work. So I am very active in the local community as well. So. Uh, uh, there is a I'm very passionate about the ethics around AI,
Hmm.
and driving community discussions around the ethics of AI, the implications of AI for non-technical audience through fireside chats or a speaker series is something I've started doing, right, and that's part of the AI collective, which is just like the AI Accelerator Institute. It's a non-profit, helping disseminate through subject matter experts knowledge about AI to the broader community. So, LinkedIn, to answer your question very simply, Keshavan, LinkedIn is a good place to see what I am usually up to.
Yeah.
Yeah.
Yeah, for everyone listening, if you've enjoyed this podcast, thank you so much. You've made it so far, and we'll see you again in the next episode.